Welcome class to this short video screencast lesson, and our topic is simple machines and forces. So let's get started on this activity. So simple machines and forces. What's a simple machine? Well, basically a simple machine changes the direction or the amount of force needed to move a load. Below we have 3 examples of simple machines. Let's do the interactive activity of the wheel and axle simple machine. In a wheel and axle, the axle and the wheel are attached to one another. Let's take a look at a situation where the axle is 1 centimeter in diameter and the wheel is 5 centimeters in diameter. Suppose that the wheel is being used to turn the axle. Doorknobs are an example of this principle. When you turn on the doorknob, it turns a spindle which has a much smaller diameter. If you were to try to turn that spindle on its own, you'd have to exert a lot more force than you do just using the doorknob. Now what about the reverse? If you have a 1 centimeter diameter axle and you're using it to turn a 5 centimeter diameter wheel, like of that in this toy car here on the bottom right, when it turns once, the wheel will also have to turn once, but it will allow you to cover 5 times the distance. In this example, the force you will have to apply is greater than you actually get out, but the distance the car travels is 5 times greater than just the one turn of the axle. Because, well, it's actually, the wheel is much bigger than the axle, right? So when it turns one distance while touching the ground or the road, it will move that much more. It will move the vehicle or the toy that much further ahead. But let's look at this further to make it more simple. So to overcome the extra effort required to turn the axle, many applications such as a real car use a motor to turn the axle. So in this example, the relationship between the axle and the wheel diameter is a distance multiplier relationship. In the doorknob example, the relationship between the wheel's diameter and the spindle diameter or the axle diameter is a relationship of force multiplier. Mechanical advantage. The distance that the wheel turns compared to the distance that the axle turns produces the mechanical advantage. You can find the mechanical advantage by dividing the diameter of the wheel by the diameter of the axle. For example, a screwdriver with a handle that's 25 millimeters in diameter and a shaft 5 millimeters in diameter has a mechanical advantage of 25 over 5, or basically 5. This means that you get 5 times more force in the shaft than you put in when you turn the handle of the screwdriver. In the case of a ceiling fan, where the diameter of a fan blade is 100 centimeters and the diameter of the axle is 10 centimeters, the mechanical advantage in terms of distance would be 10. Now, let's take a look at these 3 examples of wheel and axle simple machines. Okay guys, so it's your turn now. Let's see if we can solve these problems and find out what the mechanical advantage is. Well, if we look at the merry-go-round, it has a wheel diameter of 2.5 meters and an axle diameter of 0.25 meters. How do we find the mechanical advantage? Well, it's the diameter of the wheel divided by the diameter of the axle. Take a few seconds to see if you can get this yourself. Okay, great. If you just punch that in on your calculator, you should get wheel diameter divided by axle diameter, which would be 2.5 divided by 0.25, which gives you 10. Let's check it out. Yep, sure is right. Let's move on to this bike, where the axle diameter, that being the pedal, is 2.5 centimeters, and the diameter of the entire wheel is 50 centimeters. So, what's 50 divided by 2.5? Should be 20. Yep, good work. Now let's look at the steering wheel. It's got an axle, the steering column, okay, which is our axle for this steering wheel machine, is 3 centimeters in diameter. But the steering wheel itself, what we hold on to, is 30 centimeters. So wheel diameter divided by axle diameter, 30 divided by 3. What's that? Yep, 10. Let's move on, guys.